Right. Going back into our nice app, and we want to go down. And so we were playing with accelerometer, and now we play with gravity. So the gravity is kind of the same sensor, but it actually provides a different measuring. And the way it works is the following. It fixes the Earth gravity, assuming it fixes. You can see on the right side of the screen, it's 9.807 something. We have those three sensors, X, Y, and Z. Now, combined, they should be equal to the gravity because we are on the Earth. Assuming this phone is not detecting any movement or is not, there's no force, other acceleration on it, or self-changing its velocity. Assuming that, we know that X square, say blue square, plus green square, plus red square, in a square root, should be equal to G, or 9.807. No one needs to know that by heart. Okay, move to another variant of accelerometer sensor, would be a linear accelerometer. A linear sensor out of the accelerometer is trying to understand what is my movement. In the gravity, we assume there's no movement. Here, we want to take out the gravity and only detect the movement or the changes in my speed or velocity. This is the linear accelerometer. Right, let's look at that thing in a demonstration. So now we can see that things are moving, and relatively it's not so sensitive to my position because it avoid, it's minus, it's ignore, it take out of the equation the gravity. So in a way, the phone or the sensor computes its orientation and then subtract that from the values. By that, it's been able to detect the linear movement. I'm doing that, and I see a huge movement. Well, let's do it again. I'm doing that, and I see a huge movement in the blue line. I'm doing that, and the same thing happened in the red line. Well, I was not very accurate, but yeah, you can see where I'm going here. The red is 10 times more than others. And last one will be the green. Yeah, that sensor allows us to detect not only the amount of force, but also its direction. Assuming you have your orientation and you know what is the impact, maybe it's mainly the red or mainly the blue, you can know its direction. It might be important, for example, to know which airbag you should actually operate or inflate, and maybe other airbags you might not want to do that. It's extremely important to know that in terms of making this decision of a car that is being involved in, in a car accident, cars are constantly detecting changes in the accelerometer, in maybe other forces, and mostly you need to get a very, very accurate and rapid, in real-time decision whether this impact requires opening an airbag. This decision, and having this decision as accurate as possible, is doable mainly using MEMS accelerometers and other sensors that we're gonna use them afterwards. But keep in mind that it's not, those sensors are not only for toys, drones that want to be able to know whether it's 5 degrees forward or 10 degrees backwards, but also mission critical sensors that could help me to get the right decision in a millisecond that might save lives.